In this video, we will be looking at trigonometric function values for complementary angles. Okay, that's great, but what does complementary mean? Two angles are said to be complementary if their sum equals 90 degrees. Take this right triangle for example. Let's call it triangle ABC. This triangle is right-angled at vertex B. Let the measure of this angle be theta. This is the triangle we normally look at to understand trigonometric functions. What is the most important property we have learnt about the angles in a triangle? Yes, the sum of all the angles of a triangle equals 180 degrees. As this is 90 degrees, these two will add up to 90 degrees, which means they are complementary. As this is theta and this is 90 degrees, the third angle has to be 90 degrees minus theta. Observe this triangle closely. Look at angle A and angle C. One angle is theta, the other is 90 degrees minus theta. Their sum will always be 90 degrees. This tells us that the two acute angles in a right triangle are always complementary. So in this case, angle A is the complementary angle of angle C, and we can also say that angle C is the complementary angle of angle A. Both angles are complementary angles of each other. So what's so special about the function values of complementary angles? Let's look at this triangle on a new page. We will be computing the trigonometric function values of these two angles. That is, find the sine, cosine, tan and so on of theta and 90 minus theta. And after we find the values of the functions, you will realize what's special about them. Let's start with our code SOHCAHTOA. Sine is opposite by hypotenuse. Let's find sine of theta first. Side opposite to theta is BC and the hypotenuse is AC. We can write sine theta as BC by AC. Now let's try to find the cos of the other angle. That is cos of 90 minus theta. Cos is adjacent by hypotenuse. The side adjacent to this angle is BC and the hypotenuse is AC. Hence it equals BC by AC. Wait a moment. These two values are equal. Both are BC by AC. So we can say that sine of an angle is always equal to the cosine of its complementary angle. It gets even more interesting. Now let's try to find the sine of this angle. That is sine of 90 minus theta. Sine is opposite by hypotenuse. For this angle, opposite is AB and hypotenuse is AC. It means sine of 90 minus theta will equal AB by AC. And let's find cos of the other angle now. Cos theta. Cos is adjacent by hypotenuse. Adjacent is AB and hypotenuse is AC. So this will equal AB by AC. Wow, even these two are equal. So the cosine of any angle is equal to the sine of its complementary angle. So remember these two things. The sine of any angle will always equal the cosine of its complementary angle, and the cosine of any angle will always equal the sine of its complementary angle. Hang on, that's not all. We will look at more special relations later. Until then, keep these two special relations in mind.